Om Swastiastu. Hello guys, welcome back to my channel, and today I want to tell you about my presentation about heat treatment of steel from subject metallurgy. And so this is my profile. So there's my name, my number, identification, my identification number, my lecturer, and my class. So the base reference of my presentation is from book Metallurgy for Non-Metallurgists, edited by Reardon. 9.1 The iron carbon system. Steel are irons with a small amount of carbon alloying. Iron by itself it has a limited structural usefulness because it is soft like most pure metals. One way to increase the strength of a pure metal is to add appropriate alloying elements for solid solution strengthening. Carbon as a small interstitial element also can increase the strength of iron by solid solution hardening. However, solubility of carbon in iron is very limited, which imposes limit on solidation hardening of iron with carbon. Common phase in steels. Heat treatment of steels require an understanding of both equilibrium phase and the metastable phases that occur during heating and or cooling. For steels, the stable equilibrium phase includes ferrite, austenite, graphite, and to some extent cemented as a very stable iron carbide. The metastable phases are perlite, martensite, and bainite. The phases are summarized in Table 9.1 and described in more detail in this chapter. First, 9.2.1 Cementite and perlite formation. The equilibrium iron phase diagram applies when temperature is held constant or when heating and cooling rates are slow enough to approximate equilibrium or isothermal condition in three types or level of carbon alloying. First, eutectoid steels with carbon content near the eutectoid point of 0.77% or point G in picture 9.1. Hypotectoid steels with carbon content below in eutectoid compositions, and last hypereutectoid steels with carbon content above the eutectoid composition. Eutectoid steels and perlite formation. The definition of eutectoid point on a phase diagram is the solid state version of eutectic melting point, like eutectic transformation during solidification. Eutectoid point on a phase diagram is where a single solid phase transforms completely at once temperature into a mixture of two or more totally new solid phase. Hypotectoid steels. Steels with less than 0.77% C are called hypertectoid steels, when low carbon steels with up to 0.30% C or medium carbon steels with 0.30 to 0.60% C are slowly cooled from the austenite phase. Some low carbon averate form first along austenite grain boundaries in the two-phase Y or Y plus A region of the phase diagram. Second, 9.2.2 Martensite. As noted, martensite is a metastable structure that formed during rapid cooling. Unlike the isothermal decomposition of phase constituents, by diffusion martensite is not a phase associated with thermal equilibrium. Alloying effect on hardenability. In addition to carbon, alloying elements is also affect the hardenability and the tempering response of steels. Alloying effects on tempering response. In terms of tempering, alloying elements can help retard the degree of softening during tempering. Certain elements are more effective than others. Bainite. Bainite is distinct metastable phase in steels that occur when cooling rates are not rapid enough to produce martensite but are still fast enough so that carbon does not have enough time to diffuse to form pearlite. Like pearlite, the constituent phase of bainite are ferrite and cementite. Types of annealing treatment. Annealing treatments have various metallurgical purposes such as stress relief, recrystallizations, and spheroidization. The figure also includes the temperature gradient for the normalizing of steels, which is a heat treatment to improve the uniformity of steel microstructure. Stress relief annealing. Annealing at subcritical temperatures below AC1 includes three different temperature regions. The first in the temperature range for stress relief annealing. Recrystallization annealing. When cold work metals are heated to a sufficiently high temperature, the badly deformed cold work grains are replaced by new strength-free grains. Spheroidizing. Depending on the time temperature exposure of steels, the cementic carbides in steels can form different morphologies, such as the lamellar cementite or of pearlite, or a network of cementic along prior outstanding grain boundaries in hyperrutectoid steels. Normalizing of steels. Steel is normalized to refine grain size, make its structure more uniform, make it more responsive to hardening, and to improve mechanability. Furnace heating and induction heating. Heat treatment of steel involves a wide variety of methods for annealing, normalizing, hardening, and tempering. Fuel-fired or electrically heated furnaces are used in a wide variety of configurations with various media. Furnaces are also used for thermochemical treatments such as carburizing or nitrating. Furnace heating. Heat treating furnace can be generally classified as either batch or continuous furnace. Batch type furnace where loads are placed in the furnace. The furnace and its loads are brought up to temperature together, and depending on the process, the furnace may or may not be cooled before it is opened and the load removed. Continuous type furnace, which operate in uninterrupted cycle as workpieces pass over stationary hearth or the hearth itself moves. Induction heating is a method of heating electrically conductive materials by the application of a varying magnetic field whose lines of force enter the workpiece, which stem from this non-contact method, and its generation of heat within a workpiece are aids to automation and control, reduce floor space requirement, quiet and clean working conditions, suitability for integration in the production line or general work area due to the elimination of secondary or radiated heating, and last self-monitoring capability. Effect of heating rate on tap formation temperature. When full annealing or full austenization is required. One important factor, especially with induction heating, is the effect of heating rate on the upper critical temperature for complete austenitization. So guys, thank you for watching my video. Hope you like my video. Sorry for my misunderstanding words. See you on the next video. Bye bye.